Today we're going to learn how to solve a system of equations by graphing. But first we need to know that a system of equations is a set of two equations that share a common solution. So we have been doing a lot with linear equations. Now we're going to have two linear equations together. We call that a system of equations. The solution to the system is the intersection of the two lines. Intersection just means where they cross each other. Graphing is one method that we use to solve systems of equations. We will learn a couple other methods as well, but graphing is where we're going to start so that we can actually see what the solution looks like. So we have two graphs here, and we have the two lines. We have to figure out where they intersect to find the solution. So this point, remember when we write an ordered pair, we put x comma y. So the x value of this point is 1, and the y value is 2. I go over 1 up 2. So 1 is my x value and 2 is my y value. So our solution is the point 1, 2. On this graph, they intersect here at this point. Again, we want x comma y. The x value of this point is at 0 because we don't go left or right at all. And then our y value is at -1. So the solution to these two lines is 0, -1. Now we're going to graph and find the solution. So all of these are in slope-intercept form. When we graph in slope-intercept form, remember we start with the y-intercept. So this one will be at -4. And then our slope is 1 over 2, positive, so we go up 1 over 2, up 1 over 2. I would suggest making at least 3 points if you can, because it will help make a straighter line. It is more difficult to find the solution if you don't have a nice straight line. Our next line starts at 2 on the y-axis. And if there's no number here, we can add a 1. So it's -1, and if there's no fraction, we can put over 1. Negative means we go down, so down 1 over 1, down 1 over 1, down 1 over 1. And we can see that these two lines intersect at this point here. And this point is 4, -2. So the solution to this system of equations is 4, -2. The next example, we're going to start at +2. And our slope is -2 over 3, so I would go down 2 over 3. Again, we want to try to have 3 points if it fits on our graph, and make sure we use a ruler to have nice straight lines. Our second line, we start at -6. And our slope is +2, so I'm going to go up 2 over 1. Up 2 over 1. These lines intersect at this point here, and that is at 3, 0. So 3, 0 is the solution to this system of equations. There are always some special cases. So if two lines never intersect, we've talked about this before, two lines that never intersect, we call those parallel. And they have no solution. Because The solution is where the lines intersect. If the lines never intersect, they can't have a solution. So that would be an example like this one over here. I see this red line and this blue line. They are parallel, they're never touching, so this has no solution. You can also write it with a 0 and a line through it. The other special case is if the two lines are the exact same. So here we can see the red line is on top of the blue line. They're exactly the same line. If that happens, we say there are infinitely many solutions. And to shorten that up, we can say IMS, infinitely many solutions. Because if they're exactly the same line, they intersect at every single point on this line. There's a lot of different solutions. We can't say all solutions because it's not every point. This point wouldn't be in the intersection, or this point wouldn't be in the intersection. They have to be on the line. So it's infinitely many because lines go on forever, but it's not all solutions. Okay, so if we look at these last two, if I look at these two equations, I should notice that they have the same slope. And we've talked about same slope before, giving us parallel lines. But let's graph them and just double check. We would start with the first one at -3, and then go up 1, 2, 3, 4 over 1. 1, 2, 3, 4 over 1. Okay, and the other equation, we start at 1, and again up 1, 2, 3, 4 over 1. I can't fit another one, that's okay. These two lines are parallel. They have the same slope, they're never going to intersect. So we can say 0 with a line through it to show no solution. This one, the first equation, we start at 6, and our slope is -2, so down 2 over 1, down 2 over 1. Okay. And the second equation, notice this one looks a little bit different. It's in standard form. So standard form is when we use the cover-up method. So if I cover up my y, I'm looking at just 8x equals 24. So I divide 24 by 8, and I get x equals 3. So I could make a dot at x equals 3. And then I cover up my x. So I have 4y equals 24. Divide 24 by 4, we get y equals 6. And I look on the y-axis, make a dot at 6, and I see that this line is going to be exactly the same, and it's going to be on top of our first line. And when we have lines on top of each other, that is infinitely many solutions, IMS.